Okay, the cosine rule. So with the cosine rule, basically it's for any non-right angled triangle, okay? So just like with the sine rule and the area for the sine rule, okay, the cosine rule we're going to be using with non-right angled triangles, okay? So let's say we have a triangle that looks something like this. I'm going to label it A, B, and C as the corners, and we're going to label the sides A, little b, little a, little b, and little c, okay? So the cosine rule says that c squared, so the side, or 1 to the side squared, is equal to the sum of the other two sides squared minus 2 lots of the product of the two sides again, and then cos of the angle, okay? So this side here, in this example, so this side here, squared, is equal to the sum of the other two minus 2 lots of those other two sides, again, cos lots of the angle. And this lets us find the length, or a side length, of any triangle when we've been given two sides and a angle that's been given with it. Okay, so now there's other versions of this one too. It's just with the letters rearranged, but they're all the same formula. Okay, so it doesn't matter which letters you use in this formula, they're always going to be the same. Okay, we're always going to be using the same the same style, the same format, okay? So that's just for all the other ones. So let's jump in and have a... Oh, actually, before we jump in and have a look at an example, I also want to mention too, okay, you might notice that if we ignore this part of the formula, okay, we've got c squared is equal to a squared plus b squared, which is the Pythagorean identity. So, you know, Pythagoras Theorem, c squared is equal to a squared plus b squared. So, why do we have that extra bit? Well, if you think about a right angle triangle, okay, and we label it the same way, we've got C, we've got A, and we've got B, okay? If we label it like this, and we use our formula, C squared is equal to A squared plus B squared, and we add on this extra bit for that formula, if I put 90 degrees into here, so cos of 90 degrees, okay, we know that that's equal to 0, which cancels this thing out. So that leaves us with what would Pythagoras Theorem be. So it's a cool little trick. This is basically like the full version of Pythagoras' theorem. Okay, it's just that for Pythagoras' theorem for right angle triangles, we don't include this bit because the cos of 90 degrees is equal to 0, which would cancel that out completely. Okay, because it's all multiplication. So let's have a look at an example and see how this is done. So in triangle XYZ, XY is equal to 7 centimeters, YZ is equal to 6 centimeters, and Y is equal to 60 degrees. Calculate the length of XZ. Okay, so pretty straightforward. So let's draw a picture. So we've got X going down to Y, and that is 7 centimeters. Okay, we've got Y going to Z, which is 6 centimeters, and we know that Y is 60 degrees. And what we're asked to do is find, well, what is this here, okay? So, and we're also asked to find the exact length, okay? So, because we've got the 60 degrees here, it's going to be pretty easy. So let's use the cosine rule. So c squared is equal to a squared plus b squared minus 2ab cos c. Okay, and substitute some values in. So little y squared is equal to, now, doesn't matter which way we put these sides in because the sum of two values is the same regardless of the way we put them in. So 7 squared plus 6 squared minus 2 times, and again it doesn't matter which way you put these ones, but I'll just do 7 and 6, times cos 60 degrees, okay? So y squared is equal to, so 7 squared is 49, plus 6 squared is 36, minus 2 times 7 times 6, or 7 times 6 is equal to, 7 times 5 is 35, so 7 times 6 must be 42. So doubling 42 gives us 84 cos of 60 degrees. And let's actually calculate what cos of 60 degrees is. Cos of 60 degrees, well, think of your triangle, okay? So if you're not super familiar with this, I would suggest that we make sure that we are. because we can quickly get our trigonometric ratios or our exact values straight from this. Okay, so remember, this one comes from an equilateral triangle that's been cut in half. So 60, this 60 splits up into 30, and then that becomes 1, and then using Pythagoras you get the root 3 there. Anyway, so using this the triangle to help us with our exact value, cos of 60 degrees, 1 on 2, so it's a half. So cos of 60 is a half. And of course you could just remember what that value is. So y squared is equal to this, so y squared is equal to, now we're going to actually put this all together so that we can actually get a value out. So 49 plus 36 makes 50, 85 minus, or 84 and half of that is again just back down to 42. So y squared is equal to 85 minus 42. Okay, so 5 minus 2 is 3, 8 minus 4 is 4, so 43. So y is equal to the square root of 43, and that's our exact value. Okay, so that's just the cosine rule and a simple application of that value.